Hello everyone and welcome to this video where I'm gonna demonstrate to you the effect of Mip-Mapping in OpenGL, C++ and GLSL. So the objective of this video is to demonstrate to you the effect of having Mip-Mapped textures in an OpenGL application. So what is a Mip-Map? A Mip-Map is just a way of sampling a texture with different detail labels so that the texture will use different sampling techniques if it is farther or closer than the viewpoint, so that it will have less details the further the object with the texture is, and it will have way more details if it is closer. So the main effect of having Mip-Map textures is that we don't have this moire effect that you can see here on the screen. So we have a plane here in this OpenGL application, and some parameters that we can change on the left. So you can see here that I don't have any Mip-Mapping effect at all, and you can see that there's this moire effect happening here the farther we look on this plane. So this is because I don't have any Mip-Map implementation for the texture when I load it, so we see the effect very well here. For now, the texture is filtered by a nearest the nearest implementation possible. So if I get very close to the texture here, you can see that it's sampled as nearest color every time. But if I change it to linear, we can see that it's smoothed out, and it samples it differently by taking the linear interpolation for the texture, so that we don't have these pixels of the nearest pixel color for each pixel fragments. So the linear is a way of smoothing a texture the closer we are to it. But what I want to demonstrate to you now is Mip-Mapping. So we have two different Mip-Maps texture implemented here: nearest Mip-Map and linear Mip-Map. So it is the same as these two, nearest and linear, except it implements Mip-Mapping in it, obviously. So if I activate the nearest Mip-Map, we can see that the moire effect around disappears, but we can still see some delimitation here and here, because it also samples the texture in a nearest way. So we can see some delimitations here and here, but we can see also that the moire effect disappear because we activated Mip-Mapping. So we sample different sizes of the textures in our application for objects that are farther, and when it is very close like that, we have a bigger texture that we can sample on, and we can see that it disappears. And if I activate the linear Mip-Mapping, we can see that this delimitation here disappears, and it's very smooth and linear all the way. You can see here there's no more moire effect, and it's looking a bit better than the nearest Mip-Mapping. So if I activate the nearest again, we can see that the delimitation appears a bit. The linear, it disappears, smoothed out. And if I deactivate Mip-Mapping, the moire effect comes like directly, and it's very bad for the eyes. So I'm gonna implement it again. And to demonstrate a bit of variety in this program, I also implemented 3 different textures. It's usually patterns because it shows Mip-Mapping more effectively. So I also have a brick texture here that you can see also the moire effect on the farthest you look. And if I activate the linear Mip-Mapping, for example, it's smoothed out, and we don't have anymore this bad looking moire effect. And the nearest is the same actually for this texture. And I also have this checkboard pattern, blue, that also looks very bad if we don't have Mip-Mapping. We can see this very bad moire effect here. If I go a bit more up, we can see the effect very well here. When I move, it's very not appealing to the eye. And if I activate the Mip-Mapping, it's smoothed out directly and it's way better looking, and it doesn't move at all when we move the camera. So this is a way of subsampling a texture in a more efficient and pleasing way for farthest objects that are further from the point of view. So thank you very much for your attention.